All right, so we are going to start right at the top of 16. Again, it's going to use all those rules that we did before. And in addition, we're going to use what's called a power rule, which just pertains to your exponent. So your rule got written out at the top here. If you want to consolidate this, multiplication goes with addition. So anytime you see multiplication, you can rewrite it as addition and vice versa. And then anytime you see division, division is going to become subtraction and vice versa once we go backwards. So it says rewrite each expression using the product and quotient rule. So this is nothing new. All you're going to do is just make use of both of these. So here I would expand this into the log of 6 plus the log of A plus the log of B. Yeah. So there's no work you have to show there. Number 2, I have a quotient. So this would simply become the log of 12 minus the log of x. Done. Number 3, you have a product and a quotient. So the top product I break into a sum. So that gives me the log of 2 plus the log of y. And then what do we need around the bottom because you have the 2 terms? Parentheses. Okay. I'm going to go log of 3 plus the log of z. There is nothing wrong with leaving it like that. So I'm going to stop there. So 4, same idea. I'm going to take my product and break it into a sum. So log of 7 plus the log of c minus the log of d. And there are no parentheses necessary because it's just a d. You want to put them, you can, it's just not required. So this process right here is what we refer to as expanding using your properties. And then when you get down to question number 5, you are going to go backwards. So this one is already expanded. You need to do what is called condense. So this one we are going to condense. And often your questions can say to write as a single log. So write as single log. So I'm going to take this and kind of look and see what I have and then go from there. When I'm done, I want the word log written just next. So up here, I see addition. Addition, if we go backwards, is going to get replaced with multiplication. And then when I see minus, subtraction is going to get replaced with division. Because again, you can use those interchangeably. So really that's all I can show for work. Now you're just going to kind of jump to your answer. You're going to write the word log just one single time. And then the 2 plus log x becomes 2 times x. Where I see minus, I draw a division sign, and then y. Again, I'm sorry, there's really nothing else I could really show you for work on that one. That's kind of it, other than writing the operations above it. So that matches up here. So number 6, you're going to do something similar, but you just don't have your multiple choices. This is already expanded, and you want to condense this so that you can solve it. So your task is to condense this into one single log. So minus is going to be associated with division instead. So I'm going to go log base 4 of x divided by 3 is equal to the log base 4 of 15. I just like to distinguish those, so I like to use parentheses. This is back to what we did again the first day of this unit. When you have equal bases on both sides, which in this case you do, they're not exponential, but they're both logs. You are permitted to omit these bases and solve. Again, only when they're in the same on both sides. So what I'm left with is just an x divided by 3 equal to a 15. I'm going to place that over 1 and then cross multiply to give me 45. All right, so yes, you can still drop those bases, but they have to be the same. So number 7 says to solve as well. So I want to solve. I see this time I have addition. So addition is going to get rewritten as multiplication instead. This is an example that you have to check. And when you check it, these expressions must be greater than 0, implying that you can have no negatives or it can't be equal to 0. So essentially you're looking for a positive number. So to solve this, I have to rewrite it. So I'm going to take this side and rewrite it as multiplication. So I go the log base 3 of x minus 4 times x plus 2 equal to 3. This is not the same as the problem above it. The problem above you had equal bases. This problem you do not. So when you do not, what you have to do is you have to take this and convert it to solve. This is a good review of that. So to convert this, your subscript comes up and these two items switch places. So it becomes 3 raised to the 3rd is equal to x minus 4 times x plus 2. Okay, these problems are, kind of the opposite of one another. So one you can cancel the bases, one you cannot. So now you're going to solve. So I have here a 27 equal to, I'm going to multiply this. So x times x is x squared plus 2x minus 4x gives me negative 2x and minus 8. So I'm going to factor this once I get it equal to 0. So I go minus 27, just like you did before. We are left with 0 equal to, bless you, x squared minus 2x minus the 35. And then you're going to apply your trinomial factoring to finish and solve. So we need these to multiply to be negative 35, add to negative 2. Negative 7 and, yeah, good, positive 5. And then you're going to t-chart, and then you're good. So your possible answers are a 7 and a negative 5. And now you want to check these and see if these are going to work or not. So if I plug my 7 in, each place that I see the parentheses, all I care about is this has to be positive and not equal to 0, obviously. So if I plug 7 in, 7 minus 4 is 3, so that's fine. 7 plus 2 is 9, that's fine. What do you guys notice about the negative 5 though? What happens when we sub it in? Becomes a negative. And that's your first answer that does get rejected. So my only valid solution here is just going to be that 7. I see a lot of you writing answers like that, so I wanted to do this. So then we introduce a new rule today, and this deals with your powers instead. Now, when we did powers for exponents, what you did for powers is you multiplied. So one way that you can take your log here, if you have, for instance, the log base 2 of 4 to the 3rd, you can write this out 3 times using your multiplication. What you will also see here with your logs is when you have this power, what we typically do is bring it right down in front to multiply it. So it still uses that multiplication we did with exponents, it's just rearranged a little bit different. So with exponents, I want you to jot down that exponents go down in front and get multiplied, just like that. So exponents go down in front of the log and get multiplied. And get multiplied. Again, same rule applies. So with this one, what I can do is I could obviously type this in a calculator if I wanted to, or I could break this into a sum and do it that way as well. I if I broke this one into a sum, you would have the log base 2 of 4 plus another log base 2 of 4 plus another log base 2 of 4. And again, do this really quick. If you don't want to use your calculator, you're just asking yourself, 2 raised what power gives me 4? So that would be 2 all across the board here. So your answer just becomes 6. Again, you can do it by hands. You can do it in the calculator. You've got either option available to you. So we're going to work with your power rule as far as your properties go. So the expansion and condensing again too. So these say rewrite using a power rule for logs. So your power goes down in front and gets multiplied. So all I have to do on this one, again, power down in front with multiplication. So my answer is just 4 log x. So again, you just turn it into multiplication. My next one, power down in front. So I would have 2 log of y. Next one, power down in front. It's multiplied, so 5 log of a. That's it. So just one more rule. Now you're going to put all 3 together. Now, as these get a little bit more complicated and you have more to them, these are ones I often advise you at least do one step of work on, just so that you don't have to do so much in your head. So like number 11, I would advise that you take this product and split this first. So what might be helpful is to rewrite this as the log of x cubed plus the log of y squared first. So that's your product rule, and then power down in front, power down in front. So my answer is 3 log x plus 2 log y. So again, you just got 2 things to do with that one. Number 12, I have instead a quotient. I think it's helpful to deal with that first. So I'm going to split this into the log of a to the 4th minus the log of b to the 3rd first. And then I'm going to drop both powers down in front. So 4 log of a minus 3 log of b. So 13, you have everything. You have a product, a quotient, and a power. So I'm going to go slow. I'm going to split the top. So we have the log of x plus the log of y to the 5th. And then where I see division, I'm going to replace that with subtraction. Then you're going to take your power down in front to finish. So what remains is the log of x plus 5 multiplied by the log of y minus the log of 2. Okay. And again, that guarantees that you can at least get partial credit in case something gets done incorrectly after that. So 14, again, I'm going to advise you write at least one step out beforehand. So this is log of 8 plus the log of c to the 6th. So there's your product rule, and then power down in front. So log of 8 plus 6 multiplied by the log of c. All right, so 15, I'm going to take this and, I don't know, I guess with this one, because you don't have a ton going on, it's probably easiest to just do both of these at once. Product and power. So I would have 2 multiplied by the log of x plus the log of y. So if you'd like to do it like that, you could. Or you could distribute and go 2 log of x plus 2 log of y, because it does have to go to both. So either way with that one. 16, you have all of your rules as well. So I'm going to take this and go log of 3 minus parentheses log of a squared plus log of c. Then you're going to drop power down in front. And if you would like to leave it like this, you certainly could. So 2 log of A plus log of C. Right. So 17. You're going to take this, it's already expanded. You have to put it back together. So anytime you see the word log written multiple times, you have to go backwards. We're going to take this and go backwards. So this C that was down there was originally right there. So I know I would have B raised to the C plus means multiplication. So you're just looking for that answer, which is just choice A. Again, there's not a lot of work that you can show to support those. So it's kind of like you just look at it and then try to put it back in your head. All right. So last couple where you're evaluating. So number 18, there are no variables whatsoever. So all you have to do on this one is calculator. So in your calculator, you're going to type in a 2, and then you're going to type log base 3. I know we've gone through that before. So you go 2, and then math, and then you're going to go up to log base, type in the 3 and the 1/9. So answer as, I guess, I expect you to do that one by hand. So what's going to change here now is that you do actually have a variable, so you're going to have to do this one by hand. So the first step you want to look for is because this was down in front, you've got to put it back on. So I rewrite this as the log base 4 of 5x squared is equal to 3. So this is the log base 4 of 25x squared is equal to 3, and then you're stuck. When you're stuck, you have to convert. So I'm going to rewrite this as 4 to the 3rd is equal to 25x squared. And then that should help significantly. So 4 cubed is just 64. And then what we want to do here is get x by itself. So you're going to divide by the 25 and then just take your square root. Divide by 25. So if you reduce this just becomes 8/5 equal to x squared. And then lastly, you're going to square root. That work out nicely? Probably not. So square root of 8/5, math enter really does not convert for you. I don't know, I'll just call it 1.26. 1.26 is equivalent to your x value, or you could just leave it like that, I suppose. Well, we can learn everything up to 19. Pretty good? Okay, just a couple more. So this expression, all you have to do is put it back. So no work required. Put it back. Put it back. That one doesn't have a power. So I would have here x squared minus means divide. The 3 goes back on the y, and the z gets multiplied. All right, let me answer that. Yep, thank you. This one. Again, there's not really any work you have to show. Number 21, I'm going to skip. That's just calculator. All you would do is type those in. I'm thinking the only one that's not going to be equivalent if you type these in should be this one. Okay, but this is just calculator. You guys have that available now, so we don't really need to do that. All right, so 22. I want to do just 22 and 23 and then stop. So 22. You're going to take this sum and you're going to rewrite it as a product. So I would have the log of x plus 2 multiplied by x plus 5, and that is equal to a 1. You have not seen this yet, at least I don't believe you have. Anytime a log does not have a base, So the little subscript. It is implied that it is a common log base 10. So what you do is you put a 10 here. So that's called a common log base. Now I take this and convert it. So if I convert it, it becomes 10 raised up to the first is equal to x plus 2 multiplied by x plus 5. And now you're able to solve this normally. So I have a 10 equal to, I'd have x squared, I'd have 5x and 2x for 7x, and plus 10. Really nice thing about that is your 10s are going to cancel for you. And I'm left with 0 equal to x squared plus 7x. This one's a nice quick factoring. So you've got a GCF on both sides, and then you've got x plus 7. So your two possible answers here are going to be x equals 0 and or x equals -7. And again, you have to check these. If you take 0 and you plug it in, 0 plus 2 is positive, 0 plus 5 is positive, that's good. But what's wrong with the -7? It gives you, yeah, absolutely, it gives you a negative, so that's out. Okay. So don't forget to check those. You're going to see more and more now that how it's going to work. And then 23 is where I want to finish with. So 23, when you have an exponent, you want to immediately take this power down in front. I'm left with 19 log base 2 of 5x plus 7 is equal to 57. Just like you did, again, first day of this unit, you want to try to isolate. So I'm going to divide by the 19 and go from there, because I believe this is even. 57 divided by 19. 3. It is. So we get the log base 2 of 5x plus 7 is equal to 3. Now it's simplified. You have to convert. So I'll quickly check. So I get 2 raised to the 3rd power equal to 5x plus 7. 2 cubed is 8, and then 5x plus 7. All right, so -7, and then divide by 5. All right, so we have x is equal to a 5th. And if you plug 1/5 in, it's not going to produce any answer that is 0 or negative. You are all set. Okay, so that just combines all 3 properties together with a little solving as well to start. So you've got 10 minutes to get a good start on homework. So your homework, I'm thinking, do you have a front and a back here? Yes. I'm going to do this, I think. On 15 through 20, if you'd like, just do 15 and 16. If you'd like, if you want to do them all, because I don't want to give you too many. If you want, you can do more of them if you have time. But if you'd like to stop yourself right at this portion, then I understand, because again, I don't want to give you too much. So homework is everything up to number 16, please, and then take your time and make use of your last 10 or so minutes.